All right, today we're looking at 8.2 prep. Number one wants us to divide the polynomials. We're going to do this with synthetic division. We have 6x squared plus 3x minus 6. We're going to divide by x plus 9. Okay, so if we set the denominator equal to 0, we get a negative 9. That's going to be our box number. And then our coefficients will be 6, 3, and negative 6. We're going to bring the first number straight down. And then 9 times 6 is going to give us 54. That'll be negative. We subtract, and that gives us a negative 51. And then a negative 9 times negative 51 will give us a positive. It'll be 459. And then we will subtract 6, and that would give us 453. And this would give us a resulting polynomial. So we'll start with x squared. This will be 6x minus 51, and then plus 453 divided by the divisor of x plus 9. We want to determine if the function is even, odd, or neither. So this is referring to symmetry. So I'm only going to focus on the ones that we're looking at. So we're going to compare the original function. I'm just using f of x, that's the standard, to f of negative x. If these two are equal, then it's even. Then we will compare f of negative x to negative f of x. If these two are equal, then it is odd. Alright, so we're using g of x in this case, so we already have the original g of x. Okay, so that's like our original f of x. We're going to find f or g of negative x and then negative g of x, and then we'll compare those. So g of x is equal to 7x to the 4th plus 2x squared minus 9 all over x to the 5th. Okay, so here's the long and short of it. We're going to be either multiplying the function by a negative with a negative on the outside, or we will be placing the x, a negative x raised to a power. So if it's an even power, then it's going to come back out positive. If it is raised to an odd power, it's going to come out being negative. Okay? So either there's going to be a sign change or there's not going to be a sign change. That's pretty much what we're looking at. And so to do the g of negative x, I'm just going to kind of talk you through it. We're going to be changing the sign if it's odd power, leaving it the same if it's even. So I will be plugging a negative x to the 4th. It's even, so it's going to stay positive. So this is going to be 7x to the 4th. Plug a negative x here. It's even, so it's going to stay positive. 2x squared. This does not have an x, so it's going to stay the same. So the numerator is the same. On the bottom, however, we have an odd degree. So when we plug in a negative x, it's going to come out odd. So I'm just put that negative out front, but it'll be a negative x to the 5th. Doesn't matter if you put the negative on the top, bottom, or out front, it's the same. So here is g of x, here's g of negative x, and then I'm going to do one more iteration that is going to be a negative on the outside. So the negative on the outside just pretty much multiplies the negative on the outside. You can distribute it through the top or through the bottom. I'll just leave it out front, which I'm going to do that, just leave it out front, and this will be 7x to the 4th plus 2x squared minus 9. None of the other ones will be affected. And then x to the 5th. Okay, so now I'm comparing these answers to the original. Okay, looking for symmetry. So when I compare g of x to g of negative x, that's this case, everything is the same except for the positive and negative. This makes them different, so it is not even. Then we will compare the negative g of negative x to the negative g of x. Everything is the same, and we both have negative. So this tells me that this function is odd, has odd symmetry. And so therefore we will say the function is odd. And then it says state whether the function is symmetric with respect to the y-axis, origin, or neither. So when it says even, that means y-axis symmetry. When it's odd, that is origin. Now there's one more we could check that they don't show. It is comparing this positive g of x to the negative g of x. That would be x-axis symmetry if those two are equal. But we mainly just talk about even and odd. So do be aware that just because a function is even does not mean that it can't be odd, because we can have functions that are both even and odd, or basically have y-axis and origin symmetry. So don't think even and odd in terms of numbers. So the fact that this one is odd means it has origin symmetry. So the function is symmetric with respect to the origin.